Welcome back to part 4 of the anode filters refining video series. Before we proceed, I wanted to give an update here. Someone in the comment section for part 3 had made a remark about some precipitate settling out after I allowed it to settle overnight, and that's what's happened in here. In this one, you can see I don't have much in there, maybe a little, but in this one there is quite a bit of precipitate that is formed, and so what we're going to have to do is refilter this now. I'll have to filter both of these solutions again to get that precipitate out. I'm not going to do that on camera. I'll add this solution that's going to contain mostly silver into the cementation bucket. Any gold or platinum group metals will cement out onto the copper. I won't lose them. I'll get them back when I melt that cement silver into granules and run it back through my silver cell. Here's our silver cell cranking along at 3.5 volts, 1.9 amps. I've got a wire to spare here. I'm going to fix that. But if we look down here at the cell itself, this is about 3 days worth of growth in here. And we're going to look inside the silver cell and look at the glory of that, man. Look at that beautiful pure silver crystal growing in there. Here's a shot looking down into the anode filter basket here. And what we're going to do is I've got some more pure silver or impure silver shot that we're going to feed into it. This has a golden color. Someone asked what the color is, and that's from the 1 to 2% copper composition of this impure silver. And so that's what gives it that color. So what we're going to do is add some more impure silver shot into the anode filter now. Get this thing topped off. Get this anode bar on there. Alright, we got the anode filter full of impure shot, and I'll top that off again this evening before I go in and go to sleep. Here's the readings on the power supply. These are the solids that we extracted all the silver out of here. There's going to be some platinum group metals in here and gold. This is the precipitate that we rendered with DMG from the silver solutions. And what I'm going to do is I'm going to add some hydrochloric acid to each of these beakers now, just a couple 100 milliliters. And we'll cover them up, put them up on the heat. I rinsed as much of the silver out of here as I could, but there's still going to be some silver in there. There's no way to get it out 100%. And we're going to add some heat to both of these. We're going to start adding small doses of nitric acid to each one of these. This is going to form aqua regia inside these beakers when it hits the hydrochloric acid and start dissolving the metals for us. We've got platinum group metals in here. They're very dangerous in solution, and this can't be done in your backyard. You got to have a fume extractor to be able to do this. No way to safely do this without a fume hood. Alright, these have been on the heat now for about 5 minutes. They're starting to react. I'm going to put a couple more squirts of nitric in this one. And I'm going to have to keep an eye on the this one over here. I've had this precipitate dissolving in aqua regen, had it run away on me. Delayed or runaway reaction when I add nitric acid to it. So we're going to go ahead and keep a close eye on this one. Okay, this has been on for about 25 minutes. I want to look under here and see if I've got any undissolved solids. And I see just a few little pieces. Here you can see there's still a few chips of looks like yellow precipitate that have not dissolved. Here I've got gloves that go all the way up to my elbow, my shoulders here. Got the sash down on my fume hood because this stuff here is extremely toxic and we do not want to get any of it on us or be breathing any of the fumes. I think we pretty much got everything in here to go into solution as well. I'm going to use some hydrochloric acid here. And we're going to rinse down the inside of these beakers with some hydrochloric acid. I don't want to use water because water does something, forms some very strange precipitates. So we're going to rinse down the insides of these beakers with hydrochloric acid. Now what we'll do is I'm going to add a few drops of nitric acid to this over here, see if we can get the rest of that precipitate to dissolve. I don't know how this is going to react. Oh yeah, look at that. This stuff loves to run away on you when you add nitric to it. I probably got about 5 drops of it in there. I squirted the rest in. Hopefully they don't take off on me. Got some distilled water here. If it starts to shoot up towards the top, we can pull the lid off and try to knock it down with some water. Now we'll do the same thing with this solution over here. Just a little bit, just to see if we get any kind of reaction. And this will tell us if we've got all the material in here to dissolve. That's about a half a milliliter. Okay, I think what we'll do now, pull these down off the heat and let these things cool. I've allowed the solutions to cool down to room temperature, and now I'm adding some ice to try to chill it down even further. This should help us when we go to filter these solutions. I'm going to go ahead and start filtering the solutions now. I'm wetting the filter paper with some hydrochloric acid. I want to avoid using water. because water forms a weird precipitate. So now we're going to take our solution here that's been chilled, and we're going to go ahead and filter this. This is the precipitate that we rendered with DMG that's been dissolved in aqua regia. I've rinsed the filter over and over with some hydrochloric acid. And you can see now the filtrate is coming down through there. It's clear, so it's safe to conclude that we've rinsed all of the precious metals solution out of our filter. Wet the filter with some hydrochloric acid. Okay, here we go. We're gonna take our other solution now and get this filtered. There we go. Let's get the rest of this material in this filter. I'm going to use hydrochloric acid to rinse it out of the beaker. Here's what's left in the filter. So now we're going to rinse the funnel real good with some hydrochloric acid. Now the filtrate coming down out of the funnel looks a little bit yellow colored. So what we'll do is we're just going to pour some hydrochloric acid in here and rinse these solids out until we get a clear filtrate coming out down here. Our filtrate is running clear now. I think it's safe to conclude that we've got all the precious metals pulled out of this filter now. This is the solution that we removed all the silver with dilute nitric boils and collected the black residue in a filter. So now what I'm going to do, this is going to have gold and platinum group metals in it. So I'm going to set this back out of the way. What we'll do is we're going to pull this one up. This is our DMG precipitated palladium material. And this should just have platinum group metals in it. So this will be the easiest one to deal with. This will be the one we'll start with. Here's our filter. We'll add that to our paper storage. I'm going to get this out of the way now. We're going to add our palladium solution to a big beaker here. Looks like coffee. Let's do a stannous test. Get a little bit of this solution on a piece of filter paper and hit it with some stannous chloride. Boom. Got precious metals in solution. You can see the stannous test is turning green, and that indicates that most of this is probably going to be palladium. Okay, I'm fairly certain that there's not going to be any gold in here. What I've got is some pure zinc metal, and now what we're going to try to do is use this pure zinc to cement the platinum group metals out of here. This should go fairly rapidly because it's a highly acidic solution. I've got it in a large beaker so that we can contain the potential to flare up like that. And when this is reacting like this is putting a finely atomized spray of platinum group metals into the air. That's why I'm doing it in my fume hood. If I didn't have this fume hood drawing the air away from me, I'd be breathing finely atomized droplets of platinum group metals. And if you think, if you don't understand why that's so dangerous, look up the word platinosis on the internet, and you can read about what illness a person would get by getting some of this platinum in solution on your skin. Here you can start to see some of the black specks of the platinum group metals that are coming out of solution onto the zinc. That black material right there is our precious metals, palladium, mostly palladium. There we've got a piece of zinc that's floated to the surface. It's only taken about 2 or 3 minutes to get both of those pieces of zinc to go into solution. I'm going to add another one here. Here you can see the color of the foam turning from orange to a gray color, and that means we're getting close to having all of the platinum group metals cemented out of that solution. We're about 10 minutes into the reaction, and I think we've got pretty much everything cemented out in there. I think there's still a small piece of zinc left in there. We've got every bit of the zinc dissolved out of here now by the acid in that solution. I'm rinsing down the sides of the beaker with some distilled water. If you look down in there, you can see our metal. It's a black powder that settles to the bottom of the beaker. Still has a little bit of color to it. I'm going to drop in one more piece of zinc here. Try to chew up the rest of the acid and get any remaining precious metals that are still in solution to come out of that solution. I'm going to reach in here with a piece of filter paper, get some of that solution on a piece of filter paper. We're going to test it with some stannous here and see what we got. Looks like no reaction. You can see the solution is starting to turn a pale yellow color. That's because some of the metal's trying to go back in solution. What I would normally do at this point is get those solids out of that solution, start rinsing them off. But if you notice, right there we've got some red material in there. Red tells me that we've got some copper in here. So we're going to have to figure out how to deal with that. For right now, I think what we'll do is call it quits for part 4 here. I want to leave this in this solution and see what happens overnight. And this will conclude part 4 of the anode filters recovery and refining. Thanks for watching.